Okay, so we are doing lesson 3.2, angles and parallel lines. So one thing that you need to do on your notes, if you didn't already, is make sure at the top right of your notes page where all the postulate and theorems are, you need to draw, oh, I drew the wrong picture. You need to draw two parallel lines with a transversal cutting through. Remember, to show that it's parallel, you do that with the arrows. And then we need to label the numbers. This is just going to help you for when we're labeling the corresponding alternate interior, same side interior, and alternate exterior angle. Okay, so let me skip Alright, so the first thing we're going to look at is a postulate. So postulates we don't have to prove, so we can just go through our definition. One thing you just have to make sure is that we're looking at two parallel lines now. So remember, this is the symbol for parallel. So we're going to write out our definition. We have, if two lines are parallel, and they are cut by a transversal, then the angles are congruent. So remember, this is our congruent symbol. So what we want to do is we want to look at our picture and identify which ones are the corresponding. So that would be 1 and 3. We also could say 2 and 4. Next we have 8 and 6. And lastly, 7 and 5. Alright, so that's our first term. I'll let this sit here so everyone can copy down. Okay. Alright, so looking at example 1, it says the measure of angle 8 equals 121 degrees. So where we see 8, we want to fill in 121. Okay, so we have that there. And then let's look at what we need to find for letter A. Angle 3 is what we're looking for. Okay, well, looking at 3 and 8 as a pair, they are corresponding angles. So we can also say that angle 3 equals 121 degrees because we know by corresponding angles postulate that if they're corresponding, they are the same. So we would just need to make note of that. Okay, now the next one, we're looking at angle 1, right up there. Now, 1 and 8 are alternate exterior angles, but we haven't learned anything about those yet. So we want to think back to the last few chapters, and angle 1 is actually a certain kind of pair with angle 3, and that would be vertical angles. So by using vertical angle theorem, this tells us if two angles are vertical, then they are congruent. Okay, so if angle 1 is what we're looking for, but we already know that angle 3 is 121, so angle 1 equals angle 3, well then that means angle 1 is also 121 degrees. Oh, so we're using that, so we would want to just say vertical angle theorem. Okay, because it does say, tell us which postulate or theorems that we're using. Okay, so I'll let you guys finish writing. Next slide. Now we're looking at alternate interior angles. So if you look at your picture, so an example of alternate interior angles would be 2 and 6. So for this theorem now is if two lines are parallel, remember this is the symbol for parallel, and they are being cut by a transversal, then the alternate interior angles are congruent. So very similar to what I said about corresponding angles. So like I said, angle 2 and angle 6 were alternate interior angles, so now we can say angle 2 is congruent to angle 6, and angle 3 is congruent to angle 7. So I'll give you a minute here. All right. Okay, now we have another one. Same side interior angles. Remember, your textbook does call these consecutive interior angles. We're just going to use the same side. Now, this one's a little bit different. So if you look at your same side interior angles, so that would be 2 and 3 are a pair, and 7 and 6. If you look at them, they don't look congruent. So that's definitely not an option here. So for these two, it's still going to start out the same way. If two lines are parallel and cut by a transversal, then the same side interior angles are supplementary. So remember, supplementary means they add up to 180 degrees. So we can't just go ahead and say, well, 2 and 3 add up to 180 degrees. We'll actually write out angle 2 is angle 3 equals 180. And then we'll say angle 7 plus angle 6 equals 180. That's definition of supplementary angles. All right, our last one here, alternate exterior angles theorem. So just like the other ones, if two lines are parallel and cut by a transversal, then the angles are congruent. The alternate exterior angles are congruent. So if we look at our picture, an example of alternate exterior angles would be 1 and 5. So we would say 1 is congruent to angle 5. And then we would look at 4 and 8. 4 is congruent to angle 8. Now, if you notice on your notes there, I accidentally typed again, alternate interior angles theorem. You can cross that one out. We already did that. And next, we're actually going to do a quick proof, and we're going to prove why alternate interior angles are the same. Okay, so let me scroll here so we can see. Okay, so what is given is that A and B are parallel, which you can see from the triangles on our line. And then T is the transversal, because T is cutting through those two lines at two different points. So that's our given. So we want to look at angle 2 and 4 go together here, is what they're saying are congruent, and 6 and 8. So we look at our picture. Well, if we look at 2 and 4, those are actually corresponding angles. So if you look back on your corresponding angles postulate, we know that those are going to be congruent. And looking at 6 and 8, those are also congruent. Now, one thing here we have to be careful. So what I just did is I just said that 2, 6, 4, and 8 are all the same. And we know that that's not true even by looking at our picture, so we have to make sure we draw those second arcs. Alright, so like I said, this would be then our corresponding angles postulate. Alright, down to step 3. Now we're looking at 5 and 2 being together. Well, looking at 5 and 2, those should be review. 5 and 2, we think about our emoji, so those are vertical angles. So this would be vertical angle theorem, which is on our best friend sheet, and says if two angles are vertical, then they are the same. Looking over at 8 and 3, we got the exact same scenario down there. Alright, so for 4, we go ahead and we look at, well, 5 and 4, they're saying are congruent. Well, we know from our vocab that those are alternate interior angles, but we're trying to prove that it is. So we need to go up and we need to use steps 3 and steps 2 to help us. So what we want to look at is any angles that are repeated. Well, I have an angle 2 here, and then I have an angle 2 here. So if 4 is congruent to 2, but 2's down here, and that's congruent to 5, then I know that 4 and 5 are going to be congruent, which is what's in step 4. Now let's go over and look at 6 and 8. I see 8 here, but then I see 8 down here. So if 6 is congruent to 8, and 8 is repeated and is congruent to 3, then we know 6 and 3 is congruent. And this is your guys' favorite postulate, or property, transitive Haack. So by doing that proof, we can now say then we know that alternate interior angles are congruent. Alright, so with your partner, I would like you to spend maybe 2 minutes, I'll be kind of watching the timer here, and think about how you can find angle 2. One thing to make sure to do is write down which postulate or theorem you're using. Alright, so everyone for angle 2 should have also gotten that the measure of angle 2 equals 122 degrees. So 1 is right here, 2 is right here. So we know that those are alternate interior angles, so we need to say that we used alternate interior angles theorem to decide that. Okay, so that should have been okay. Let me move on here. Alright, this next one is a little bit different because now we're looking at variables. So what we always want to do when we're given these expressions here is we want to go over and plug them in. So angle 1 is 16x minus 8. Angle 2 is 4 times y plus 8. And lastly, angle 3 is 14x plus 2. One thing you have to be careful is if there's two separate variables, you can't just set them equal. We see that 1 and 2 are a very special pair. They're an alternate exterior angle pair. But if we set angle 1 equal to angle 2, we run into 16x minus 8 equals 4 times y plus 8. We will get stuck with the y and the x. That's not going to help us, so we don't want to do that. We want to look at where the variables are the same. So I see 16x minus 8 and 14x plus 2. So angle 1 and angle 3 are congruent because of our corresponding angles postulate. Now, if two angles are congruent, we know from last chapter that the measure of angle 1 is going to equal the measure of angle 3 by definition of congruent angles. From there, we can look at the expressions that we have. We know angle 1 is equal to 16x minus 8, and then we know angle 3 is equal to the 14x plus 2. We're now just using substitution, and we know this is Po because we have an equal sign. From here, it's just our algebra. Move over our 14x to give us 2x minus 8 equals 2. We add 8 to give us 2x equals 10. Divide by 2 to give us x equals 5. So we did the first part. We found x. Now we need to go over and look at y. For me to be able to find that, well, I know that 1 and 2 are the same. For me to now find angle 1, I need to plug my 5 back in. So angle 1 now equals 16 times 5 minus 8. So we have 80 minus 8, which is 72 degrees. So like I brought up earlier, angle 1 is congruent to angle 2 by alternate exterior angles theorem. And just like we did the first one, we know the measure of angle 1 is equal, oops, forgot my M, to the measure of angle 2 by definition of congruent angles. Angle 1 we said was 72, and angle 2 is 4 times y plus 8. We have a special property we need to apply here, distributive property, to give us 4y plus 32. Move our 32 over with subtraction to give us 40 equals 4y. Divide by 4, so y equals 10. Alright, so a pretty long problem there, so I'll leave this up so you guys can take a look at it for a minute. Alright, let's move on. Last thing, perpendicular transversal theorem. So I did give you a picture. So very similar, I mean, we're talking about perpendicular, so that's the symbol, 90 degrees. And then we have the transversal. So if we have two parallel lines cut by a transversal, and that transversal is perpendicular with one of the lines, then it is ultimately perpendicular with the other. So if you look at your picture, I don't know which way it's drawn, maybe this way, if we have two parallel lines, give it our arrows, and then we have our transversal. If I told you that the transversal is perpendicular with only the top one, you then would know, well, perpendicular, okay, that's 90 degrees. Well, this angle right here, that 90 degrees, is corresponding with this one down here where I just put that little dot. Well, corresponding angles we know are the same, so this ultimately gives us another box, which we know is 90 degrees. The box tells us that the two lines are perpendicular, so that's how that one works there. I'll leave that up there for a moment. Okay. And then next, with your partner, you're going to work on page 182, just numbers 3A and 3B. So this is right after the example there in your book. This is just, you guys are going to do the solving for X and Y stuff again. So just make sure that we can just pause it here and you guys can work on this. Please check around the room and make sure that you guys are getting it sorted out and figured out, and then you guys can turn it in to the sub, and I will give you participation points for this. All right, and I think that's it. I will see you guys on Tuesday.